Okay, Assalamualaikum. So this is the example on the view factor. Okay, so for this first example, this example we cover on the uh, two rules, which is summation and reciprocity rules. Okay, so we have these two concentric sphere. So the blue one and the grey color one. Okay, so basically the grey color one is an enclosure to the blue color one. Okay, the blue color one is a surface one and the grey color one is surface two. So like what I teaching you before, for this one, how we can calculate the view factor, we use the concept of the end surface. For the end surface, we will have n square view factor. Okay, so we have two surface. Basically, we will have 4 view factor. So the view factor that we need to determine is f1 to 1, f1 to 2, f2 to 1, and f2 to 2. Okay, so 4 view factor. Okay, so the first relation that we can use, okay, remember last time I show you to calculate the relations, this one. So basically these relations can use to determine the additional relation that we can use to solve our view factor. Okay, so we use that one to calculate 1 over 2 and n minus 1. Okay, so 1 over 2 minus 1. So basically it will equal to 1. So from this expression, basically one view factor from this 4 out of 4 we can directly determine. So how can we, so the other three view factor we can determine based on the summation and reciprocity rules. Okay, how to determine this first one is, okay, remember last time I mentioned about the f1 to 1 would be equal to 0 if we have a plane or convex surfaces, which is like this lah, convex surfaces. Okay, so for this case, for the surface 1, so if the radiation is radiate from surface 1, and basically it will not strike back itself because the surface is like a convex surface. So f1 to 1 would be equal to 0 in this case lah. Okay, so basically we already determined one view factor. Next one we have f1 to 2. So f1 to 2, okay, by using the summation rules, we can determine the value of f1 to 2. So remember the summation rule, f1 to 1 in the same surface would be plus dengan width, f1 to 2 would be equal to 1. So this one we already know the value is 0. So f1 to 2 would be equal to 1. Okay, so we have two view factor already, which is this one and this one lah. Okay, the next view factor is that we need to determine is f21. Okay, so we use the reciprocity rules, which is area 1 f12 would be equal to area 2 f21. So we already have the value of f12. Now we need to substitute the formula of area for sphere, which is 4 pi r square 1 f12 4 pi r2 square f21. So this one we insert with the value of 1. We become like this lah. So f21 you will get 4 pi r1 square over 4 pi r2 square. So cancel out these two, you will get for f21 you can solve using the radius r1 square over r2 square. Okay, so we have the other one left, which is f22. So for f22 we cannot use the same concept as f11 because the surface of f22 is like a concave shape, right? It's not like surface 1, it's a convex shape. So for the concave shapes, the value of f22 would not equal to 0. So to calculate, to determine the value of f22, you may use the summation rules because from the same surface, f22 plus f21 is equal to 1. So to calculate for the f22, 1 minus, we substitute this one, r1 square over r2 square. Okay, so finish on determining the 4 view factor for these surfaces. Okay, now we try to do example number 2. Okay, for the example number 2, okay, let's read the question first. You need to consider a cubicle furnace. The length is 5 meter, width 5 meter, and the height also 5 meter. Okay, same as this figure lah. So we need to assume that this surface is back surface. The base, top and side surface of the furnace are maintained at uniform temperature, which is 800K, 1500 and 500K. So determine A, the net rate of radiation heat transfer between the base and side surface. That means this one, base and side surface. Okay. So, okay. Basically, to calculate the rate of radiation, the formula is Q I to J is equal to A I F I to J sigma sorry, this one J, Ti minus Tj, power of 4. So this is the formula. I'm not sure whether in the slide I already touched about this one, but you need to use this formula to calculate the net rate of radiation, the net rate of radiation heat transfer lah. A I F J to Fi to J. So this one is Fi to J. Wait, let me erase back. Write it properly lah. So Fi to J sigma Ti minus Tj. Okay, so for the first question, you need to calculate the net rate of radiation heat transfer between the base and the side surface, which is 1 to 3 lah. So Q1 to 3 lah, you need to calculate. So this is the surface area 1. So F1 to 3 sigma T1 4 minus T3 T1 at the power of 4 minus T3 to the power of 4. Okay, so the first thing you need to find is the view factor of F1 to 3. Okay, so how you can calculate the view factor of F1 to 3? So basically we can refer back figure, this figure, wait, we can see this table and also this chart, whether we have that kind of a view factor or not. So from here we can see this, it is not applicable for this one. And also because we have a cubical shape, and we need to have the surface of the bottom surface and the side surface, right? So this one is a perpendicular rectangular with a common edge, so also not applicable for us. These two also not applicable for us. Okay, so basically we need to use the rules lah, to solve the view factor 1 to 3. Okay, what rules that we can use is we use the summation rule, which is f1 to 1 plus f1 to 2 plus f1 to 3 equal to 1. So basically from the surface 1 dekat sini, so basically we need to find the view factor that radiate from here to here, to this surface. So for the f1 to 1, so basically you imagine that we didn't consider the other surfaces. So basically we can use the concept of plane surface. So the radiation from the surface 1 will not strike back itself. So this one would be 0. So the value that we need to find is either this one or either this one. But like what I mentioned just now in the table and the chart, we don't have this kind of geometry. So we have this one, f1 to 2, which is from the bottom to top and from the top to bottom. So we may use figure 13.5. Okay, this figure. Okay, so basically we can use this figure lah to calculate the value of f1 to 2. This one, this figure. Okay. Okay, from this figure I get the value of f1 to 2 is 0.2. You need to use the concept given, the information given, which is we have 5 meter here, 5 meter here, and also 5 meter here. So if 5 over 5, you will get 1 for L2 over D. This one. Try to use your ruler and try to get try draw a line and find the intersection. So definitely you can get 0.2 lah. L2 over D would be equal to 1. L1 over D also equal to 1. So you will get this 0.2. Okay. Okay, f1 to 2 is 0.2. So you insert in this formula 0.2 plus f1 to 3, that's mean 1 is equal to 1. So that's mean f1 to 3 is equal to 0.8. Okay, so you can solve for this one lah, which is q1 to 3 is equal to the area would be you have 5, 5, right? Same goes to just now, 5, 5, 5. So 5 times 5 would be 25 lah, the area. 25 times with 0.8 times with Stephen Boltzmann, which is 5.67 times to 10 to the power of 8, time with 800 to the power of 4 minus with 500 to the power of 4. Okay, the last answer, this one 1 to 3, I tertinggal. So this one would be 394 kilowatt for the question A. Okay, next you need to solve for question B, which is the net rate of radiation heat transfer between base and the top. So B, Q1 to 2 lah. You need to solve. Okay, so using the same formula, this one. So 1 to 2, A1, F1 to 2, sigma, T1 4 minus T2 4. Okay, so just substitute the value. The area still the same, which is area 1. We have 5 times 5. 5 times 5 Remember kita ada 5 meter times 5 meter times 5 meter. So that's mean this is the cubicle. So all the length inside this cubicle furnace is the same. Sini pun 5, 5, 5, 5. Okay, so just insert the value 25. So F1 to 2, you get the value of 0.2 from the figure right just now. So T1 is 800 minus with 1500 to the power of 4. So you will get the value of negative 1319 kilowatt. So basically the negativity here indicate the net radiation of heat transfer is from surface 2 to surface 1. So in here we do 1 to 2. Basically it is from 2 to 1. So that's why we get negative here. Okay, the last question is the net radiation heat transfer from the base surface. Okay, from the base surface, which is Q1 lah. From the base ni yang kita nak tahu, which is Q1. See Q1. So Q1. So how to calculate the Q1? Basically you need to Q1 to 1 plus with Q1 to 2 plus with Q1 to 3. Okay, so for the first one, this one, because there is no heat transfer occur from surface 1 to itself, so we can say that this one is 0. So Q1 to 1, you take this value, and Q1 to 3, you take this value. Okay, so the last answer you will get negative 925 kilowatt. Okay, so basically the negative sign here indicate that the net radiation heat transfer is to surface 1. It's not from surface 1, it's to surface 1. That's why you get negative. Okay, I think that's all from me for the view factor example. Thank you for your time.